Hello everybody. Let's try to do this example division problem specifically with long division. Okay, so obviously we would know it's a division problem if it says to divide, or if we have this fraction bar, this bar right here, meaning 12x squared minus 22x minus 10 divided by 3x minus 7. Okay, so that's like the signature of a division problem, either way you see it. Now, before I go into the details about how we'll perform long division of polynomials over here, I'd like to start with the example of long division of numbers. So if I was going to divide 22 by 7, like the way that I learned it in elementary school, then I would set it up like this. So already it kind of looks like how we would set up long division of polynomials, all right? And what I do from here is similar to what I do over here, okay? So when I'm dividing numbers with long division, I choose a number such that if I multiply it by 7, I'll get as close to 22 as I can without exceeding it. That would be 3. 3 times 7 is 21. 4 times 7 is 28. All right, so I want 3. So I choose 3. Then I multiply 3 by 7. I get 21. And then I subtract 22 minus 21. And I get 1. Okay, and that's the entire process for long division of numbers, at least like this. This will be similar, okay? I start by choosing something such that if I multiply it by 3x, I'll get a match with 12x squared, an exact match, okay? So, all right, in that case, this would be 4, because 4 times 3 is 12, but 4x, because 4x times 3x is 12x squared. So I choose the 4x because I want something such that when I multiply by 3x, I'll get 12x squared. Okay, so I chose that. Next, I multiply 4x times the entirety of 3x minus 7. If I do that, I'll of course get 12x squared, 4x times 3x, and then I'll get negative 28x, right? Because I'll take 4x times negative 7. 4 times 7 is 28. I get negative 28x. So I chose this, and then I multiply it by the entirety, both terms, 3x minus 7. I get what you see here. Okay, now the next step is similar, as I said, to what happened over here. What did I do at this stage over here? I subtracted. I said I got to take 22 minus 21. So same thing, I need to subtract this. I'm taking all of that and I'm going to subtract this. So think about it. If I subtract 12x squared, I'm just going to be subtracting 12x squared. What if I subtract negative 28x? Well, when you subtract a negative, that's a double negative, then it amounts to adding, all right? So with my red pen, I wrote the operative sign here. This is going to be subtraction. That's going to be addition, okay? All right, so let's do that now. I get 12x squared minus 12x squared. So that would be 0. Those cancel, in other words. I get negative 22x plus 28x. Okay, that will be 6x. Okay? All right. Now, one other thing to notice about this, notice how, like, when we do long division of numbers, everything's organized by place value. Here's the ones column, here's the tens column. Same thing here. Everything is also organized by place value. Here's the x squared column, here's the x column, here's the number column, all right? So I guess you could say that I also have a plus 0 right here, okay, because there's not another number. And so I also have negative 10 plus or minus nothing. So I'm going to have minus 10 like so. Okay. Now, this long division process is really just the step that you saw, but it might need to be repeated. Okay. I need to repeat this process of choosing something here, multiplying and matching the leading term here until I have just a number left over. So I could still continue this process further, okay? So for example, like there is something that I could choose and put here such that when I multiply by 3x, I'll get 6x. Okay, so I repeat that first step, but now on this. So that would be plus 2, wouldn't it? 2 would do it. So I choose the 2. I multiply 2 by 3x, and I do get 6x. But I multiply 2 by minus 7, I get minus 14. See, so it's that same first step, just repeated. All right. And just like once I chose and multiplied, I would then subtract, same thing here. Okay. So I'm going to take this and I'm going to subtract this. So this will turn out to be subtraction, but this will turn out to be addition. All right. Okay. So I've got everything worked out. Okay. 6x minus 6x, 0, canceled as intended. You know, these match, they'll always cancel. Then I get negative 10 plus 14, so I get 4. So now I'm done. When I'm left with just number on this kind of problem, then I'll be done. Okay, now I need to extract the answer out of this. Like, this is the process, and the answer's in there, but I have to like extract and say, well, here's what the final answer is. It's actually the same as how I would extract the answer with this one. So over here I did this, but I didn't tell you like, well, here's the answer. I just went through the process. The answer is this number, which is called the quotient, plus this number, which is the remainder, over this number, which is called the divisor. So 22 over 7 is the mixed number 3 and 1/7, you could say, okay? 3 and 1/7, like a mixed number, there's an implied plus there. It literally means 3 plus 1/7, okay? So same thing here, same exact thing. I take this thing, which is the quotient, 4x plus 2, and then I add the remainder, which is this number, 4 over 3x minus 7, which is the divisor, this number here. Quotient plus remainder over divisor. That would be our answer. All right. So that's the long division process. How about here's something a little bit extra. I think it's good for you to know stuff. I'd like to show you as much as I can. How do we know this is right? Like, normally in math, we can check our answer. We can prove that it's right somehow. And by checking it, I don't mean we check our work and make sure we didn't make a mistake, but like by something different, by something else, we can verify that we're right. Like, what makes 22 over 7 really equal to 3 and 1/7? Well, all divisions have something in common. Okay, if we call something division, then here's how it works. If 20 divided by 4 is actually 5, then 4 times 5 would have to be 20. All right, so that's our external independent check on our division. Now, if 4 times 5 wasn't 20, well, we did it wrong. Something's not right, okay? And you know why we say division by 0 is undefined? Why is 7 divided by 0 undefined? Like, why do we say there's no answer to that? Well, is there a number, say I put a question mark there, is there a number where I can take 0 times that number and get 7? There's no such number. There's no number you could multiply 0 by to get 7. If there was, that would be the answer to what division by 0 is, okay? At least in this case, but there's no such number. So 22 over 7 is 3 and 1/7 if 22 is equal to 7 times 3 and 1 over 7. Okay, that would mean this is right. If I take 7 times this number and I get 22. We'll say, do we? Let's see. How do we multiply 7 times 3 and 1 over 7? We distribute. 7 times 3 is 21. And what's 7 times 1 over 7? Well, the 7's cancel. You just get 1. What's 21 plus 1? 22. That's right. 7 times 3 and 1/7 is 22. Same thing with this. Okay? So let's check over here. Like I said, it's good to know something. That's my job, show you stuff. If I took 3x minus 7 and multiplied it by this, what would I get? I would get 3x minus 7 times 4x plus 2. Okay, and then I get 3x minus 7 times 4 over 3x minus 7. That's like that. So just like how I would check my division over here. Okay, all right, so if this is that top part, you know, if, as I've written right here, I can take this, multiply it by that, and get that thing up there, if I can show that I get 12x squared minus 22x minus 10, then I did it right. So let's see, 3x times 4x, that's 12x squared. 3x times 2, that's 6x. Negative 7 times 4x, negative 28x. Negative 7 times 2, negative 14. And then I get this plus 4 at the end of it. Okay, so I'm hoping to get 12x squared minus 22x minus 10. So let's see, adding the like terms, I get 12x squared, then I get 6 minus 28, that's negative 22x, and I get negative 14 plus 4, that's negative 10, and that's correct. That proves it, right? Just like 20 divided by 4 is 5, because 4 times 5 is 20. This division is also correct, because I multiplied it back out to check it and verify it. Okay, so that's a bonus. I just wanted you to see all the analogies that this has to how we do math with numbers, the way that we divide numbers, the way that we check our divisions to see that they're correct. Same thing over here, okay? So here's the long division process. I showed you that. How to extract and write down your answer from the long division process. I showed you that. And then how, as a bonus, how you could check your answer, okay? And the parallels that has to numbers. So that's 3 things in one lesson.